In this video, you'll learn about what the stack data structure is, how to implement it using Python, and some of its common use cases. Let's begin. The stack is a linear data structure that follows the last in, first out mechanism. Let's take a look at this statement in more detail and understand what linear data structure and last in, first out means. A linear data structure is where each element is connected to, at most, two other elements, the one before it and the one after it. When you try to visit all the elements starting from one end, there's just one path that you can take. That is, a linear path from one end to the other. Contrast this with nonlinear data structures like graphs, where an element could be connected with any number of elements. There are several different ends of this structure, which means that there are several different paths that we can take to travel through the entire graph. Now, let's consider last in, first out. It is exactly how it sounds. When the elements are taken out from the data structure, they are in the reverse order in which they were put in. This means that if the elements were put in the order 1, 2, 3, 4, they'll be retrieved in the order 4, 3, 2, 1. Let's see how these concepts apply to a stack. Consider a stack of pancakes, which is empty right now. At the moment, the top points towards nothing because there are no pancakes in the stack. When you want to insert a pancake into the stack, you place it on the current top and then update the top, which was previously pointing to nothing, to point to this new pancake. You can only insert a pancake to the top of the stack. If you want to insert it anywhere in the middle of the stack, you'll have to remove the pancakes from the top, then insert the new pancake and place those pancakes back again. In Program, this action of inserting elements to a stack is known as pushing. When you want to take a pancake out of a stack, you will remove the pancake on the top, then the one under it, and so on. Removing elements from a stack is known as popping. Observe that the pancakes are removed in the reverse order in which they were placed in, and at all times, each pancake was only next to, at most, two other pancakes, the one above it and the one below it. Now, let's see how you can implement a stack in code. We'll be using Python for the same. For implementing a stack, you need three things: an empty array in which you will store the data, a variable that points to the top element's position or index, and the size of the stack. To initialize the stack, you will declare an empty array of the given size, then set the size of the stack, and then set the top to -1. That indicates that the stack is currently empty. It will have the following two methods: push for inserting an element, and pop for deleting an element. The push method accepts one argument, the value that needs to be inserted. It first checks if the stack is full, that is, if the top index is equal to its size -1. If it is, then it throws an error. Else, it updates the top by 1 and places the new element at this new top. The pop method removes the element from the top. It first checks if the stack is already empty, that is, the top is equal to -1. If it is empty, then it throws an error. Otherwise, it returns the element at the top position and decreases the top index by 1. You don't need to delete the value at this point because when you insert a new value, it automatically overwrites the old value at that position. You can also have another method called seek. That just reads the value from the top without popping it from the stack. Now that you know how to implement a stack, let's take a look at where a stack is useful. A stack is useful in implementing features like undo, redo, and forwards, backwards. Think about this. When you're browsing through any website, every new URL is pushed to a stack. Whenever you want to go back, you go back to the URL that was last pushed into the stack. Similarly, when you undo changes in let's say, a Photoshop program, you undo the most recent changes and backwards from there. Hopefully now you understand what a stack is and how to create one and when to create one. Happy coding!